Unit 7 Array List, Topic 7.6 Sorting. In this lesson, we will discuss how to store elements in an organized manner. When data is disorganized, it can be hard to find or search for values easily. Organizing or sorting data can make it easier to search through data. There are three sorting algorithms you need to be familiar with: the selection sort, insertion sort, and merge sort. We will cover merge sort in Unit 10. Selection sort and insertion sort are iterative sorting algorithms that can be used to sort elements in an array or array list. When sorting elements in an array or array list, what might you notice in a sorting algorithm? You will need to traverse the data structure using a for loop or a while loop. You will need to identify a minimum or maximum value depending on if you wish to sort in an ascending or descending manner. You will need to compare elements to each other. Are they greater than, less than each other? And in some cases, you will have to swap elements to place them in their proper positions. Let's explore each algorithm in more detail. We are going to start by looking at selection sort. This algorithm sorts arrays by repeatedly finding the minimum value in an array and moving it to the front. Let's take a look at what it means. Using selection sort to sort this array, we pick the first index in the array to start. Then, we traverse the list to find the minimum value in the rest of the list, which in this case is 1. We swap the current index with the minimum value. Now the value at index 0 is sorted. Next, we move on to the next index, 1. We find the minimum value in the rest of the list, which is 2. The minimum value is then swapped with the current index, and the current index is now sorted. We then move on to the next value. Find the minimum value in the list, swap it with the current index. Notice the pattern? Now the current index is sorted. We'll continue in this process until the whole list is completely sorted. Did you notice the pattern? Patterns can become algorithms. Here's the pseudocode for how we can write this algorithm. We want to traverse each index in the array up until the second to last element. We will then find the minimum in the rest of the list and swap the index with the index of the minimum value. As we can see, this algorithm is broken down into 3 distinct steps. Let's take a look at each so we can put this together. First, we want to traverse each index up to the second to last element. We can do this by writing a for loop that starts at 0 and goes to array.length -1. You can modify this boundary based on the data structure you're traversing, such as array lists or string values. You might be wondering why we want to go to the second to last element. When we are stepping through the selection sort, we can see that the second to last element in this case is 6. When we swap the value at index array.length -1, we are putting the array in the correct order, as the final value is swapped into the correct place. As a result, we do not need to evaluate the final index, as it must be sorted correctly if all the other elements are in the correct position. Therefore, we can stop the traversal after the second to last element is swapped. Now that we have the traversal established, we can start focusing in on the other 2 tasks. First, let's figure out how to find the minimum value in the rest of the list. To find the minimum in the rest of the list, we need to do a couple of things. First, we need to set the current index as the minimum value. Then, we want to traverse from the current index to the end of the list, looking for a value that is lower. If the value of an index later in the list is lower than the current index, that index is the new minimum. We want to start by setting a new variable, minimum index, equal to the current index. Then we want to create another traversal from the current index to the end of the list. The selection sort algorithm contains a nested loop. We set int j to index +1 so that the traversal starts at the index following the current index. This way, every value after the current index will be evaluated, and the loop ends once every value following the current one has been looked at. Next, we need to set up the if statement that checks if any of the values are smaller than the current index. If the value of the index is smaller than the value of the current index, we set the minimum index to the new index. Now that we figured out how to find the minimum value, we need to swap the value of the index and the value of the minimum index. A swap takes 3 lines of code to complete. First, we need to create a temporary variable to store the current index value. Then, we need to make the current index value the minimum index value and set the minimum index value to the temporary variable value. This might seem confusing, so let's explore this in more detail. If the current index 0 is storing the value 5, and the index that is storing the minimum value is at position 3, we need to swap these values. We do this by creating a temporary variable. First, we store the value of the current index in the temporary variable. Then, we make the value of the current index the value of the minimum index. Then we store the current index value in the minimum index. The temporary variable makes the swap possible. We can code this out like such. The value of the current index is set to temporary. Then the value at index is changed to the array minimum index value, and then the array minimum index is set to the temp. This follows the general template for how we can swap any value in Java. Let's put all these things together. Notice how the index or positions of values are the star of the show in this algorithm. As we can see, this algorithm is separated into two distinct components, all within a for loop, finding the minimum and swapping the values. If we wanted this to be cleaner, we could use top-down design and decomposition to condense these into two distinct methods, find minimum and swap, with each performing one function in the selection sort. Selection sort can be visualized as shown in the animation here. As data is traversed, the current index is swapped with the minimum value. We can see that the array is being sorted in order from index 0 all the way to the final index. The 7.6 Daily Video 1 walks through selection sort in arrays and array lists. You should check it out.